Hey guys, my name is Ayush Maharaj. Welcome to my demo for InterviewIQ. This is a project that I built at the 24-hour UC Berkeley AI Hackathon with my teammate Evan Anderson in June of 2026. We built this project as kind of an opposite spin on a mock interview platform, where instead of candidates practicing their ability to take on an interview and be asked questions about the job, instead, what we did is we made a platform for employers and founders where essentially they can practice giving interviews to candidates. So, to get started on our platform, what you want to do is add a job title and description for whatever job you want to practice your interviews for. And then what will happen is candidates will be generated. So, what's happening behind the scenes here at a pretty high level is that we have some agents that are working to create candidates with one candidate that's already predetermined to be the best fit for the job. So, here we can see the three generated candidates alongside their resume and some very relevant skills to the job. Notice that the resumes for each of the candidates are templated differently, essentially reflecting what a candidate pool might already look like. Now we're going to get started on the interviews.
Hi, thanks for having me. I'm Saoirse Diallo. I'm excited to learn more about this opportunity.
Before we get into this interview, I wanted to get into more depth with how the technical side of things works at this stage. So when our candidates are generated, we use Claude Sonnet 4.6 to take in the information about the job title and job description, and then generate three distinct candidates, all with varying levels of fit for the job. And one of those is automatically predetermined to be the best fit for the job. Then what we do is we take three interview agents. So since we have three candidates, of course, this is an adjustable number. We could have done four, we could have done five. For this demo's purposes, we're going to stick with three. And so what happens is we also generate three interview agents. So when you go into the interview, these interview agents are provided with their own resume. And then also they're given two models to speak and for the person that's using the application to also speak. So we use DeepGram's Aura 2 text to speech, which essentially what it'll do is it'll take Claude's response and speak it back to you. So that way it sounds like you're talking to somebody. And then we use the Nova 3 model, also from DeepGram. That's their speech to text model, which essentially takes in what you say, converts it to text, and passes it to Claude. And then that's how the conversation works. Now, in terms of how we've technically defined candidates, we use a variety of techniques to try to get candidates to kind of be as realistic and as human as possible. We use candidate archetypes. For instance, a candidate might be really strong and the best fit for the job. Some candidates might also look really strong on paper, but maybe they're very shy and they aren't able to reflect that as well in the interview. Also, there might be candidates who are really weak and are very clearly weak in the interview, but then there are also candidates that might be weak, but they are very verbose and they speak with a lot of technical depth. And so it's hard to figure out that they aren't actually a good fit until you get into a lot of depth in the interview. So we added these archetypes that are randomly decided when the candidates are generated, so that interviewers have to essentially dig deep to find out who the actual best candidate is. We also added stuttering, and stuttering is completely randomized. And so that makes it a little bit more realistic to what an actual candidate might sound like. And then lastly, we also added rings of knowledge, which is essentially a way for us to limit Claude's huge breadth of knowledge down to what we'd expect out of a human candidate applying for the role. If you imagine a Claude agent applying for a job in marketing and you give it a really, really difficult lead code problem, it would probably be able to solve the really difficult lead code problem, even though the job is for marketing. We wouldn't expect that out of a student marketing intern. We probably wouldn't expect that person to solve a really difficult lead code problem. And so, considering although this is an edge case, we wanted to make sure it was handled. And so what we added was rings of knowledge. So essentially, anything that appears on the candidate's resume, the candidate will have a decent understanding and be able to provide a decent answer to any question that's kind of related to its resume, obviously, depending on how strong of a candidate they are. And then any adjacent concepts, the candidate should also be able to provide a probably not as good, but a somewhat decent response. And then anything outside of that scope, so concepts on the resume and adjacent concepts to that, to the concepts on the resume, anything outside of that. So, like the example I gave with asking a marketing intern a leak code problem, it would generally just give a clumsy attempt or not even try to solve the problem and then just redirect the conversation back to something more relevant to the role. Some features we added as part of the interview stage include a code editor that the candidate can edit, a transcript that lets you see the chats as text as part of the interview. Also, we have some interview notes, and we also have a barge in threshold that essentially lets you adjust what level of volume will cause you to interrupt the candidate depending on maybe where you are. Maybe you're in a noisy room, or maybe you're just in a silent room. Hey there, how's your day going today?
Yeah, doing pretty well. Thanks for asking. A little nervous, I guess, like you always are before one of these, but yeah, good overall. How about yourself?
I'm doing pretty good. To get started, can you solve twosome in our code editor here?
Yeah, absolutely. Let's do it. Go ahead and throw the problem at me, and I'll get started.
Yeah, so the problem, as I stated earlier, was LeetCode's twosome.
Oh, sorry, I think I might have missed that earlier. Could you restate it? Like, I want to make sure I'm solving the right thing. Is it the twosome problem from LeetCode?
Yes, that's what I'm talking about, obviously.
Oh yeah, of course. Sorry about that. Okay, so twosome, the idea is you're given an array of integers and a target, and you need to find two numbers that add up to that target and return their indices, right? Let me think about this for a second. So the straightforward way I'm thinking is just like two nested loops. Go through every pair and check if they sum to the target. It's not the most efficient thing in the world, but it gets the job done. Let me just go ahead and code that up. So I'll loop over each index I first. And then for each I, loop over.
Hey, I'm going to pause you right there. Instead, can we just do the O of N approach? I want to see you try to solve that first.
Oh, yeah, of course. Sorry. The O of N approach. So the idea there is to use like a hash map, a dictionary where you store values you've already seen, and then for each number you check if the complement, like target minus the current number, is already in there. Yeah, let me clear this out and try that. Okay, so I'll define the function and then create an empty dictionary to store like the numbers I've seen so far. Python def to sumnums target seeing equals, and then I'll loop over the array. I need the index too, so I'll use enumerate. Python for inum in enumeratinums, then calculate the complement, what I need to find to hit the target. Python complement equals target num.
Hey, why aren't you writing this in the code editor? You're just kind of spitting it out. Please write this stuff in the code editor.
Yeah, sorry about that. Let me actually put it in the editor properly. So starting with a function definition and the scene dictionary. Okay, and then I'll loop over nums with enumerate so I get the index too. And then calculate the complement. So that's target minus the current number. And then check if that complement is already in scene. If it is, return the two indices. Then if not, just add the current number to scene and keep going. And I think that should be it. The lookup in the dictionary is O of 1. So the whole thing is like O of that overall. Does that look good to you?
Yeah, that looks perfect. Thank you so much. I think we will end the interview right there. Thank you. You did great.
Thank you so much. That's really great to hear. I appreciate the kind words, and thanks for the opportunity. It was a good conversation. I hope to hear back from you, and hopefully we can work together. Thanks again.
Now we have a separate agent that essentially runs through the chat transcript and generates an interview summary. Feel free to pause and have a look at the interview summary for yourself, and then we will move on to the next interview.
Hi, thanks for having me. I'm Kwame Kim. I'm excited to learn more about this opportunity.
Hey Kwame, tell me about your experience at Meridian Analytics.
Hey, yeah, thanks for having me. So Meridian Analytics, I've been there since March 2022, so a little over 3 years now. It's a SaaS platform, analytics focused, and I'm on the platform team, so we're kind of the backbone layer that other internal teams build on top of. Day to day, a lot of my work is around building and maintaining RESTful APIs in Python, specifically Fast API. We have a pretty large PostgreSQL database, and I do a lot of work with SQL Alchemy on the ORM side. We're also using Redis pretty heavily for caching. And then on the infrastructure side, things are containerized with Docker and deployed on AWS. So EC2, RDS, S3, that kind of setup. I'd say one of the things I'm most proud of from that role is just the culture around testing and code quality. We have a solid CI/CD pipeline, and I've kind of been a champion for making sure we've got good test coverage on the services I own. Not perfect, but better than a lot of places I've worked. So yeah, it's been a good run there. Happy to go deeper on any of the specific technical pieces, if that's helpful.
I'm having a look at your resume right now, and it says that you made a refactor that reduced average query latency by 18% across 3 high traffic endpoints. Can you tell me more about that?
Yeah, for sure. So that was a pretty interesting project actually. We had these 3 endpoints that were getting hammered. They were like our most trafficked ones, used by basically every customer-facing dashboard. And we started noticing that response times were creeping up, especially under load. So the first thing I did was just kind of look at what the queries were actually doing. We were using SQL Alchemy, and I ran some explain analyze on the underlying Postgres queries, and it became pretty clear that we were missing some indexes in the right places. There were a couple of join conditions that were doing full table scans where they really shouldn't have been, and then the other piece was we weren't caching aggressively enough. We had Redis in the stack already, but it wasn't being used on these particular endpoints. So I added a caching layer there with appropriate TTLs based on how stale the data could reasonably be for each one. And then the third thing, which was maybe more minor, was just cleaning up some n+1 query patterns that had crept in through the SQL Alchemy relationships. And between those 3 things, we got to that 18% reduction. I'll be honest, I don't remember the exact baseline numbers off the top of my head, but yeah, it was meaningful enough that it showed up clearly in our monitoring.
That final sentence she said was quite hesitant, and so I wrote an interview report note about it, and it will actually get pulled together into the finalized report when you get scored at the end of all 3 interviews and after you make a decision. Awesome. Thank you so much, Kwame. That's going to be the end of this interview. Thank you.
Oh, great. Yeah, thank you so much for taking the time. It was really good to chat, and I hope I gave you a good sense of what I've been working on. If there's anything else you need from me, like references or anything like that, just let me know. And yeah, hope to hear from you soon. Thanks again.
Once again, feel free to pause and look at the interview notes. And now we will move on to the third and final interview.
Hi, thanks for having me. I'm Fatima Nakamura. I'm excited to learn more about this opportunity.
Hey Fatima, can you go ahead and implement a linked list in our code editor here?
I'll implement a basic singly linked list, a node class, and then a linked list class with some standard operations like append and maybe a print or traversal method. Let me start with the node. So each node just holds its data at a pointer to the next node. Now I'll build a linked list class around it. It starts as none for an empty list. Now I'll add an append method. This traverses to the end and tacks on a new node. And I'll add a simple print method so we can visualize the list. So that'll print something like 1, 2, 3, none. That covers the basics. Do you want me to add anything else like a delete method or maybe prepend?
Yeah, go ahead and add a delete method at the very beginning.
So I'll add a delete method. It takes a value, and we need to handle the case where the head itself is the node to delete, and then the general traversal case where we look for the node before the one we want to remove. Let me add it right after init and before append. So the idea is, if the head matches, we just move head forward. Otherwise, we walk the list, and when we find a node whose star next star matches, we skip over it by pointing to next.next. If the value isn't in the list at all, we just fall out of the loop and nothing changes. Want me to test it or add anything else?
Yeah, no, that looks fine. Thank you so much. I think that's going to be it for this interview.
Great, thank you so much. This was a good time. I enjoyed it. I hope you hear from you soon.
Here are our third and final interview notes. Feel free to once again pause and look over them. And then lastly, we will get into the hiring decision across the three candidates. This was a totally random choice. I asked Kwame most about her experience at her company, while I asked the other two leak code and coding implementation questions. So I ended up just picking her and providing some small reasoning at the bottom. And lastly, we have one final candidate that determines whether or not you pick the right candidate, what you could have done better at, what you did great at, as well as key points in your interview transcripts, as well as a final score overall. So now here on the final page, you can see whether or not I picked the right person. As you can see, I unfortunately did not, and I didn't score too highly for a few reasons. And they're all listed here. Some of the things that I could have done better at was my interviews were not that thorough. My reasoning for why I picked the candidate that I picked was not that sufficient. And also, I think I was kind of rude to the first candidate. So that's also part of the reason, amongst others. And then also some things that I probably did pretty good at, but for the most part, not the best interviews. And, you know, considering I only asked one question, I think this checks out. In this section, we can see some highlighted key points in the interview transcripts and why they were good or bad. That's about all I have for today's demo. I know it was quite a long one, but I hope you guys found this project kind of cool. And if you have any questions, let me know down in the comments below. And I will see you in the next one. Bye-bye.